Hello and welcome to another episode of Military in Painful Details. Today's episode is entirely devoted to the process of designing the Bismarck and its tactical and technical data. And right at the beginning of this material, I have to admit that I may not be entirely objective in some of the opinions I put forward in this video. I admit that I don't like these ships. I have a lot of respect for German designs, especially from the period of World War I, but I am also impressed by the different approach and innovations they introduced on their ships in the interwar period. K-class cruisers or pocket battleships, they always impressed me, and I was curious how the Germans managed to achieve so much despite limited resources. And here enters the Bismarck-class battleships, big, bulky, overweight ships that abandon almost everything that German designers and tacticians have managed to achieve so far and return to the times before World War I, both in terms of technical aspects of their designs and partly in the strategy of using these units. I am always disappointed by the fact that despite much greater freedom, much greater available resources and finances, Bismarck and Tirpitz are the best that Germany put forward in that period. This comment always outrages some of the fans of these ships and ruffles some feathers, but it is what it is. Besides, I hope that after familiarizing yourself with today's material, in the worst case, you will have some insight into what raises my doubts and what is the source of my disappointment with these ships. The German fleet of World War I was designed for one purpose: to challenge and defeat the Royal Navy, the Grand Fleet. The dreadnoughts and battlecruisers of the Imperial German Navy were created as a result of many deliberations and a very specific course taken by the people responsible for the shape of this fleet. Therefore, they constituted a specific, specialized tool. Whether it made sense to create this tool is whole another matter, but the goal that had to be achieved was set, and then actions were taken to create a tool to achieve this goal. Therefore, German ships, with few exceptions, are very good warships, very well adapted to their role, in many respects equal or superior to their opponents. We also recalled the creation of a very interesting class of so-called pocket battleships, a seemingly insignificant type, but in truth quite revolutionary. The Deutschland-class ships reflect the resurgent idea of Germany designers. Using the available tonnage, ships were created that were ideally suited to their assigned tasks, causing chaos on communication lines. Interestingly, initially those warships were designed not to wage war against Great Britain, but against France, which had also had colonies that needed protection. The designers of the pocket battleships took advantage of the loophole in the provisions of the Washington Treaty and created a hybrid of a heavy cruiser and a battleship. France immediately recognized the threat and began building their own answer to this. This, in turn, put pressure on Italy. Even in the USA, it was noticed that the Deutschland changed the rules of the game a bit. You can argue that the Alaska class was a result of, among others, the creation of the Deutschland class. And this is a very impressive achievement. German designers, despite all adversities, the Treaty of Versailles, the Treaty of Washington, the economical crisis, lack of experience, lack of raw materials, created warships that influenced navies all over the world. But let's move on to Bismarck. This ship did not have as well defined a role as previous designs, in particular the Deutschland class. Was it a pure battleship for finding information with other battleships, or was it a raider capable of staying outside the base for long periods of time and with a huge range? Bismarck, as a result, was kind of jack of all trades, covering many possible scenarios with his characteristics, but in reality it was not really a good choice. Steam turbines give good performance and Bismarck was quite a brisk battleship, but turbines limit the ship's range. Bismarck could move at high speed for long periods of time and also had relatively good range at high speed. Unfortunately, the German turbines were not of the best quality. They were prone to failure. They could not that could not only delay the rider's departure to sea, but also shorten its rate, or in the worst case, contribute to the loss of the ship if they failed in a situation in which the German battleship was pursued. Deutschland class had innovative, troublesome at the beginning, relatively reliable after improvements, diesel engines, but Bismarck returned to the turbine drive. Diesel engines not only increased the ship's operational range quite vastly, but they also allow it to operate at low speed for long periods of time, or even to drift and quickly gain high power if it encounters a ship that needs to be chased. For diesel engines, full power is immediately available, but unfortunately not so for turbines. Main artillery is also the result of the lack of a coherent concept. In the case of the Scharnhorst class, this issue can be still understood. It was the first large warship built in Germany after World War I, and it was still limited by treaties and politics. But not only was Bismarck another heavy class of ships built in German shipyards, but her design and construction were allowed to go far beyond treaty limits. And yet, a rather old scheme of 4 twin turrets was chosen for it. Not only could more guns of this caliber be accommodated on a ship of her tonnage, but a larger caliber of guns could also be selected. The Deutschland class uses limitations to its advantage. The Bismarck, which is not subject to these limitations, chooses an anachronistic scheme abandoned by other navies in the world. Also, the division into the medium caliber secondary artillery and heavy anti-aircraft artillery proves a conservative approach to a problem. Although Bismarck is not that different from other European powers, it lags behind the USA and Great Britain. Bismarck was a battleship that devoted 40% of its weight to armor. However, this armor was not deployed in an effective and modern way. It was an outdated armor scheme slightly tweaked for reality of World War II. Warships of this type had thick and extensive side armor, but the armor deck left much to be desired. While other navies were perfecting the all-or-nothing scheme, recognizing air threats, long-range combat and underwater threats, Bismarck was rehashing the scheme from World War I, a scheme that made sense at that time, but not necessarily in the conditions of the new conflict. Both the choice of main artillery configuration and the armor scheme are strikingly similar to that used in the Bayern type or the Bayern class from World War I. Some historians disagree here, claiming that Bismarck was in fact a new project, but my opinion here is a little bit different. It is simply impossible to hide the striking similarities between these types, both the most obvious ones, 4 twin main artillery turrets, and the more hidden ones such as the armor scheme typical of World War I heavy warships with a low main armored deck with slopes. And although the internal division provided a considerable amount of buoyancy, it did not protect against an attack from below the water surface or against fire threatening the deck armor in a proper way. Most of these negative traits are the result of quite a simple factor. There was a big hole in German ship experience or warship experience from 1918. Although the Germans were developing the theory of naval warfare, it was mainly focused on smaller units, submarine and in theory a commercial warfare. The combat of large surface warships was stuck in a theoretical limbo, and Bismarck is the result of this. Let us quote the VDI, Verein Deutscher Ingenieur, report regarding Bismarck and the Kriegsmarine ships. What the Kriegsmarine lacked in the naval construction problem for 1933 and 1938 was proper planning, not the means of production. Work on the ship that was to become Bismarck began in 1934, before the signing of the maritime agreement between Great Britain and Germany. Adolf Hitler was already planning to withdraw Germany from the provisions of the Treaty of Versailles. Great Britain realized that it did not have the strength and means to force Germany to submit, so they signed a naval agreement to at least retain some form of control over former opponent. Nevertheless, before this happened, the first design work on Schlachtschiff F Ersatz Hanover, the ship was to replace the old pre-dreadnought Hanover, began in the spring of 1934. A ship with a displacement of 35,000 tons was planned, completely abandoning the restrictions of Treaty of Versailles. Armed with 330 30mm caliber guns, 12 150mm guns and 16 105mm anti-aircraft guns. The side armor was to be up to 350mm thick and the deck armor was to be 100mm thick. It was assumed that even though Germany would liberate itself from the Versailles, it would still be bound by the restrictions of the Washington Treaty, hence the 35,000-ton displacement limit. Meanwhile, the Germans had also abandoned any naming pretensions, and the Scharnhorst class was changed to Schlachtschiffe from Panzerschiffe, and Deutschland type was also to Schwere Kreuzer, also from Schlachtschiffe, albeit somewhat later. In October 1934, it was agreed that the new ships were to be able to overcome a new threat, the French Dunkerque class. Therefore, the speed of the new ship was originally set at 33 knots maximum speed and 21 knots marching speed. This was later slightly reduced to 29 knots maximum, but marching speed remained unchanged. Many designs were considered, but as with the Nelson class, each of the designs turned out to be just way too heavy. Erich Raeder, and the then commander-in-chief of the German Navy, decided that under no circumstances could the displacement exceed 35,000 tons, and the ship's dimensions must, again as with the Nelson class, enable construction and servicing in existing shipyards, as well as the draft. It could not exceed 10 meters, so that the battleship could pass through the Kiel Canal. However, in December 1934, when it turned out that none of the proposed designs were within the prescribed displacement, Raeder allowed the 35,000-ton limit to be exceeded, provided the gain would actually be profitable. Already at this stage, various versions of propulsion and weapons began to be considered: turboelectric drive or a classic steam turbine, armament with 330mm guns or with 350mm guns. It seemed that at this stage diesel engines were not being seriously considered. After the displacement restrictions were abandoned in January 1935, it was decided that the size limits related to shipyard dimensions should also be omitted. The maximum speed was lowered to 28 knots, the main artillery was set to 350mm, and finally, geared steam turbines were chosen for propulsion. However, the armor was left slightly thinner than in the first design, 320mm of side armor. Unfortunately, the outdated armor scheme from before World War I was still used. Thus, the bow and stern were armored with 150mm of armor outside of armored citadel. The deck armor consisted of two layers. The lower the armored deck was the main deck and was 100mm thick, and on the slopes going down to the lower part of the side belt, it was up to 120mm thick. The upper deck was 50mm thick. Displacement was estimated at around 39,000 tons. The size of the hull, particularly width, was limited by the dimensions of the Kiel Canal. In March 1935, with the abandonment of the restrictions of Treaty of Versailles, the project was revisited. Germany used the escalation clause mentioned earlier in this material because one of the signatories, the Empire of Japan, had no intention of ratifying the provisions of the Second Treaty of London. Consideration was given to changing the artillery to a 380mm guns, 15 inches, raising the displacement to 42,000 tons, well over permitted limit of 35,000 tons. Due to the fact that a naval agreement was being negotiated with Great Britain at the time, it was initially decided against increasing the caliber of the main artillery, and the ship was to be armed with 8 350mm guns in 4 twin turrets. As a side note, I would like to add that 3 gun or triple main artillery turrets were considered. even with 380mm guns, but due to the lack of a firm decision, no work on such mountings was started at that time. The changes placed the new ship at around 41,000 tons of displacement, quite advantageously as it enabled the use of Wilhelmshaven's logistics facilities. In May, however, Reeder reversed the decision to use 350mm guns and ordered the installation of 15-inch guns. This change delayed the entire project by over half a year. The type of propulsion was still being considered, but again, diesel engines ideal for a raider were not discussed. Only high-pressure turbines and turbo-electric drive were considered. The turbo-electric drive was quite tempting, but its heavy weight discouraged installation on a new ship. Funnily enough, even casemates were considered for secondary artillery, but wisely it was decided that maybe in the mid-1930s it was no longer time for casemates and 150mm secondary artillery was placed in closed mountings. Among the more interesting changes, an upper thinner armor belt was used, stretching from the main armor belt to the upper deck, and this armor was 145mm thick. It was an outdated idea because such armor could prevent penetration by lighter caliber shells, such as the secondary artillery of enemy battleships, in the event of a battle such as that of 1916. The Royal Navy never planned for this kind of fight, but apparently some customs take a long time to die. There was a reason why such a belt was considered necessary, but more on that a bit later. In August 1935, another project, A13, was presented to Reeder using turbo-electric propulsion. The ship was powered by 3 screw shafts. Many aspects of the ship were not yet finalized at this stage. Elements such as the shape and size of the superstructures, appropriate fire control stations, crew cabins, a catapult for aircraft, and even the number of anti-aircraft guns were still in the design phase. For example, the number of 3.7 centimeters anti-aircraft guns was doubled in the final design. This preliminary design was approved by Gross Admiral Erich Raeder. Therefore, a turbo-electric drive was chosen for the ship, similar to the one tested on US Navy battleships. However, in accordance with Raeder's guidelines, in order not to exceed a displacement of 41,000 tons, the design had to be slightly lighter. This was done in a way known to us from the Nelson type. The armor thickness was reduced. The armor deck near the engine room was trimmed down from 100mm to 80mm, and the thickness of the barbettes on the upper deck was reduced to 220mm from 320. In June 1936, Raeder made another change, the last big one for Bismarck design, and ultimately decided to use high pressure steam turbines as propulsion for the new ship. This change required a redesign of the entire propulsion system, again delaying the entire project. Finally, in July 1936, the keel for the new battleship was laid. The Bismarck's armor scheme is compared to that of the SMS Bayern. There are some similarities, but you can also see that there is more emphasis on horizontal defense. Bismarck, unfortunately, is indeed close to Bayern class in its main ideas regarding the armor scheme. As in World War I, the German command predicted that the naval engagement of capital warships would take place in the waters of the North Atlantic. Thus, taking into account the difficult weather conditions usually prevailing in the region, it prioritized close-range combat and consequently adapted its armor accordingly. However, the overall scheme was outdated. Unlike the other navies which primarily sought maximum armor for the largest possible volume of the ship by using thick side armor and thick deck armor, but placed high to defend against air attacks and resting on the main side belt, German designers primarily took care to protect the key elements of the ship's survival in artillery combat at short and medium distances. Bismarck not only had an armored citadel, the main armor belt was not of exceptional thickness however, but in addition she had armor extending over the main armor belt to the main or the upper deck. This additional belt was much thinner and had a constant value of 145 millimeters. In addition, the thickness of the main armor belt gradually decreased below the waterline from 320 millimeters to 170 millimeters. The underwater belt made, of course, perfect sense. It was also protection against shells falling right next to the side and penetrating underwater, as it turned out not as rare as it might seem. Unfortunately, due to the overall armor tonnage or armor weight, it did not reach as deep as maybe it should have. However, the secondary side belt was completely pointless. It added a lot of weight high in the ship, and its value against other battleships was negligible. This weight could have been much better spent on strengthening the armor deck or the side belt. Unfortunately, due to the need to protect the interior of the ship, excessively exposed by low-placed main armor deck, this belt was necessary. Otherwise, even shells from relatively light artillery like 6 inches or even 5 inches would have devastating effect when hitting the unarmored hull which was exposed. In addition to this reinforcement above the main armor belt, the bow and stern of the ship were also armored. The stern was armored with 80 mm of armor, while bow was 60 mm thick. Again, these armored sections are of very little value. They cannot stop a larger caliber projectile, they help initiate the fuse on impact, and their theoretical role strengthening the structure of the sections would be better achieved by using the armored deck extension. An additional advantage would be enhanced protection of the magazines from the fire coming over the bow or stern. The main advantage of Bismarck's armor scheme is the fairly solid armored deck, with slopes set at an angle behind the armored belt. This deck, extending from the lower part of armor belt to the anti-torpedo bulkhead, was 110 and 120 mm thick on the slopes, becoming 80 mm thick on the flat surface. A projectile fired from a medium or short distance had to penetrate first a 320 mm thick armor belt and then a 110 or 120 mm slope of the armored deck. However, taking into account the firing angles, these values were actually much higher. It was an effective solution that provided a high level of protection at close distances. However, Bismarck's armored belt was penetrated. The penetration was probably made by 16-inch shells from HMS Rodney, but they were fired from a very close distance and there was in fact no armor belt that would provide protection against such a hit. So it is not true that Bismarck's armor was not penetrated, but it is true that the said penetrations were made from a very close distance, probably because we can't be 100% sure of the distance. The gun turrets were also penetrated and their frontal armor was 360 mm, as well as Bismarck's command bridge, which also was protected by 350 mm of armor. The upper deck was 50 mm thick, increasing to 80 mm above the magazines and around the command bridge, and it extended throughout most of the ship, including beyond the armored citadel. The idea of split armor deck had its purpose. The upper deck, 50 mm thick, was to activate the shell's fuse and deprive it of its penetrating cap. The shell was then intended to strike with less force without penetrating the main 80 mm or 100 mm armored deck. Unfortunately, although the idea is right, it is not fully proven. Great Britain and USA found this out by carrying out test firings and bombing attacks on mock-up targets during interwar period in extensive series of tests. The Germans, deprived of such opportunities, relied mostly on experiences from World War I. Therefore, ultimately, horizontal armor was in fact quite inadequate to conditions of World War II. Even the total armor thickness, 130 mm, was lower than that of a much smaller King George class or even on the Nelsons. The Bismarck's great advantage was its strong transverse bulkheads protecting the citadel and steering gear, extending from 220 mm to 145mm. Combined with a 50mm armor deck, they provide quite good protection against hits coming from front or stern. Most of the vertical armor surfaces were made from reinforced Krupp steel. The horizontal armor was made of Wotan hard steel, and the longitudinal bulkheads were made of Wotan Weiss steel. The myth about extraordinary quality of German steel is often repeated. Krupp steel was at the time the second highest quality in the world, just behind steel from Great Britain. So it was certainly a high quality steel, but it was not the best steel in the world and certainly didn't have any magical capabilities. And this argument can also be used or seen when assessing the defense system of this warship. The high seas fleet ships of World War I were armored the way they were for two reasons. One, they were armored in a way that was considered best for the type of the engagement expected, that is, a close range battle. Two, this armor scheme was the state of the art in terms of ship defense at that time. Bismarck was built many years after the conflict, and yet its basic principles do not differ from those of Bayern class or SMS Seydlitz. The Germans seem to forget that already during World War I, the naval engagement could start and last at a much longer distances than 10,000 meters that the German command expected. Therefore, the relatively thin deck armor was a huge disadvantage of the Bismarck. The side belt and sloping armor deck provided good defense against shell fired from medium and short range. Did it, however, provide as good protection as armor belt that was, for example, 50mm thicker? If the dependency, one plate is better than two plates of comparable thickness from the armored deck, is to be used on the side belt, then perhaps it would be better to invest weight gained from removing the low armored deck slopes and 145mm side belt in thicker side armor. Also, the armor on the stern and bow was in fact unnecessary and was more of a disadvantage than an advantage. The armor had greater chance of triggering the shell fuse. The thin 145mm armor belt stretching from the main armor belt to the upper deck was, however, the biggest sin. Completely useless against an equivalent enemy, placed quite high, its weight cost was enormous. It is again a relic from the previous war, in which investments were made in defense against medium caliber artillery, actually even older, when the QF, quick firing guns, were invented. And quite unfortunately a necessity due to the low armor deck exposing the interior of the Bismarck of the battleship for light and medium projectiles. Bismarck devoted 40% of its overall tonnage to armor and honestly was less protected against threats than ships 10,000 tons lighter than her. As we have already mentioned, in the case of the Nelson class, in terms of armament, German designers choose a slightly different path for their heavy warships. They choose light shells, light projectiles with a very high muzzle velocity. The disadvantages of this solution include faster wear of the barrel and consequently worse accuracy, greater recoil, and worse penetration properties at longer ranges as shells lose velocity faster than heavy shells. The advantages include favorable ballistics at medium to short ranges, especially at short ranges, as well as no loss of penetration at these ranges. The past of the German fleet comes to the fore again. In 1936, close-range combat was still expected by German command. The problem would arise if the longer-range fight dragged on. The irony of fate is that Bismarck's first clash with Hood and the Prince of Wales and the HMS Prince of Wales was not to Bismarck's advantage. Most of the engagement took place at longer to medium ranges, although in fairness, British ships were in keeping with their doctrine of fighting below 16,000 yards, below 14,000 meters, sought to shorten it. The second disadvantage is the anachronistic arrangement of weapons. Admittedly, the term flow may be too strong of a word, 20 years earlier, the main artillery arrangement was a relatively modern arrangement with 4 turrets placed in superposition, 2 at the bow and 2 at the stern. By 1936, however, it was obsolete. German designers probably did not want to risk an unproven 3-gun mount on the ship, and due to the confusing design process and the late decisions to change the guns to 380mm, there was no time to develop larger turrets. Therefore, they chose a proven 2-gun turret or twin turret. However, it was a good and decent platform for mounting main artillery, heavily armored, equipped with efficient mechanism for loading and preventing fires from penetrating deep into the magazines, equipped with modern ventilation system that remove gases produced from firing from the turret. The guns were of the SK-C/34 type, and the turrets were of the DRH-L-C/34 type. SK stands for Schnellade-Kanone, quick loading gun, and the DRH-L stands for Drehscheibenlafette, rotating platform. I'm sorry for my German, but I'm also sorry for my English. I hope you will bear with it. The letter C followed by a number indicates the year of production, in this case 1934, for both systems. The guns were a proven concept developed from the guns used on Bayern class. SK-C/34 fired AP shells weighing 800 kilograms at a speed of 820 meters per second. The rate of fire exceeded 2 rounds per minute. The propellant charge was also in 2 parts as in World War I. The turrets had their own 10.5 meters rangefinder, but on turret A it was later removed due to constant flooding of this position. It was removed in January 1941. The turrets were nothing unusual, but they were heavily armored, efficiently designed and reliable, and what more do you need? The guns were also at least equivalent to other 15 inches guns. The only drawback was their quantity and in some circumstances the choice of the shell, which means that light shell with a high muzzle velocity. A potential disaster could be the penetration of the propellant magazines, which in case of Bismarck were located above the projectile magazine. Britain already reversed this order, fearing artillery fire more than underwater explosions. However, it should also be said that the greater stability of the German propellant charges would perhaps not have caused such dramatic events as on the British battlecruisers. Splitting secondary artillery is also, not the most effective solution. At the time the Bismarck was designed, other navies were already experimenting with uniform, double-purposed weapons. In Bismarck, however, secondary artillery was divided into 150mm heavy artillery and 105mm anti-aircraft artillery. Fortunately, both the 150mm and the 105mm guns are excellent guns. The anti-aircraft guns caused some problems. They were mounted on the ship in 2 waves. The first one was installed on the ship when it was commissioned, and the second one in October 1940. The problem was that the first ones were mounted on a different C/33 platform than the later ones, the C/37. This in turn required that the guns had a separate fire control. However, this was overlooked, causing the later installed guns to fire with insufficient advance notice. However, I question the credibility of this claim, of this information. The guns did indeed have different beds and platforms, but I found information about the aiming problem only in one source, so I provide this information more as a curiosity and with a little bit of grain of salt. Both 150 and 105mm guns were excellent in terms of the quality of the guns themselves, very good characteristics and highly automated. The problem was the rather capricious targeting systems, which tended to break down due to quite minor shocks and the inability to efficiently switch from attacking low-flying torpedo planes to high-flying bombers and dive bombers. Light anti-aircraft defense was provided by 16 3.7 cm SKC/30 cannons in 8 double mounts and a total of 18 2 cm cannons, 10 in single stations and 8 in 2 quadruple stations. Both the 3.7 centimeters and the 2 centimeters guns were insufficient. A problem similar to the Royal Navy and the US Navy, not to mention Japan, which had been looking for suitable small caliber anti-aircraft weapons for quite some time. The main artillery was directed by 3 artillery stations, one mounted at the top of the foremast, one forward of the command bridge, and one on the aft superstructure. The stereoscopic rangefinder was connected to the FUMO 23 radar. The control room at the top of the mast and at the stern had 10.5 meter rangefinder, and the one in the front of the command bridge had a smaller 7 meter rangefinder. Moreover, as I have already mentioned, the main artillery turrets, except turret A later in 1941, had 10.5 meter rangefinder for local control in case of damage to the station. A similar system was also used for secondary artillery. Bismarck had a very modern fire control system, very effective for its time. It was adapted from British practice, but then refined by German designers. First in secret through the Haselmeier company, the Germans learned about achievements of other nations in this field. However, they quickly began to experiment with their own solutions and created their own artillery computer, although in general assumptions it was based on the system developed by British inventor Arthur Pollen. In 1926, they adapted the Royal Navy's method of plotting the movements of enemy fleets and their own fleets. Combined with an analog range calculating computer, it was first proper artillery system fire control system in the German fleet. It was used on K-class light cruisers and pocket battleships. Initially, the elements of the system were still separated, but in early 1930s, most likely under the influence of copies provided by the Italians, the Germans began to combine individual elements of the fire control system into one syncretic computer. This type of computer, the C/38, was mounted on the Bismarck. It was a synthetic system supported by high-quality stabilized rangefinders and, unfortunately, quite capricious radar system. The whole system is quite complicated, although it is not as complicated as the British Admiralty Fire Control Table, but when it worked properly, it gave very good, even excellent results. The relatively new Bismarck crew achieved very good result in their first battle against HMS Hood and HMS Prince of Wales, if we take into account the hit percentage. The Achilles heel was capricious radar systems, which over time began to fall further and further behind the other Allies' navies. Bismarck's armament and the way it was controlled was therefore one of his strongest points. Perhaps a ship of this size could be used to mount more powerful main artillery, or to combine 150mm and 105mm artillery into one double-purpose one, but in terms of quality and control and fire control system, Bismarck was in fact a world-class warship. Bismarck had a classic propulsion system, a high-pressure steam turbine. Steam was supplied by 12 high-pressure boilers located in 6 boiler rooms. 3 sets of turbines powered a system of 3 propeller shafts, typical of German heavy warships. The problem were the boilers, which were unreliable, heavy, and the entire system had much worse efficiency than it should have, but it is also a problem of the King George class. Again, this puts a question mark, however, over Bismarck's privateering or raider role. With a range around 8,600 nautical miles, Bismarck required support to operate for extended periods of time, out of range, out of the base. On the good side, however, the system had a lot of power and accelerated this rather heavy colossus to an impressive 30 knots. 3 propeller shafts had their advantages. They were much lighter, for example, but also quite a few disadvantages. They gave, for example, less control over the ship, especially in the event of the damage to the steering gear. It is reported that Raeder initially planned at a very early stage of formulating the requirements for future battleships to design these ships as raiders, but due to Hitler's lack of consent to such use of battleships, any commercial warfare ambitions were ultimately abandoned in design phase. This is only partially true. Gross Admiral Erich Raeder's confusion regarding the selection of the appropriate propulsion for Bismarck would indicate the lack of a unified concept of using this battleship or its frequent modification during design stage, depending on the perception of other nations as potential opponents. On the one hand, they wanted Bismarck to be able to fight and defeat the ships built in France, the Dunkirk class, but on the other hand, it quickly became clear that it was not only the Marine Nationale that would be the opponent of the Kriegsmarine. Raeder wanted a turbo-electric drive for the Bismarck, which was completely unsuitable for long-term rider-type operation, let alone fuel economy. Ultimately, Raeder decided on high-pressure steam turbines to save weight, but the intent behind the decision on propulsion points us rather towards large-scale naval engagement than towards secret long-term Raider operations. And that's where we will end today's material. We will come back to Bismarck at the very end of this series, so in this episode I purposely didn't offer my summary of this design. Again, I'm a bit torn about these materials because since they were created I've gained a bit more knowledge in several important areas, and it would be appropriate to say a bit more here and there, but that would unfortunately force me to write everything from scratch. So for now, we will have to be content with how it is. Although I want to emphasize that I am aware that some things have been left unsaid, and maybe I should come back to this material in the future and talk about it in even more detail. This video should basically be watched in tandem with the one waiting in line about the British King George class battleships, King George V or King George V class battleships. I'd like us to have today's material in the back of our minds when we watch episode 5 of this series, so that we could compare the design process resulting in both of these battleships, Bismarck and King George class battleships. How the characteristics of both of those battleships were adapted to the tasks that they were assigned by their respective navies. But that will be a task for the next episode of Military in Painful Detail. Thanks for watching, please subscribe and comment below the video, and I'll be back with new material soon.